basically the whole program stops and delays for that amount of time. But we don't actually want it to stop. We want it to keep sensing and making sure that, like, once this delay is over, is there motion in the room? Do we want the fan to turn back on, or like we need it to keep. Yeah, am I saying this right?
Yeah, I think so. That's the delay statement gets you a blocking delay. What we wanted to do was to keep listening for a button press. Since when the motion sensor goes off, we want the fan to stay on for 5 minutes. But if you hit the button, we want the fan to turn off for 10 minutes. So we have these two timed loops, basically, that can't interfere with each other. And so the easiest way to make them not interfere with each other is to use what's called a timer library, and that actually uses interrupts on the Arduino board as compared to using the delay statement. And those interrupts allow you to time longer times that are non-blocking, so you can still do things during that time period.
Right. Yeah. So that's right. So when the fan is running, we want to make sure that we can still detect a stop from the push button. So that's the issue of that. So we can use the delay function that's built in. So I use Simple Timer. It's just a library that I downloaded from GitHub.
Can I also ask you to make this embiggened?
Yeah.
I think a few others. And from there, you go to Tools and adjust your text size.
Okay.
Yep. Oh, I'll turn it back on. Thanks. I thought. See if that magnifying glass.
It's on Sim Preferences.
It's a sorry here.
They're great. That's right. Yeah, font size. Perfect. Thank you.
Is that better?
Yeah, I'm trying to find the time. Like, if I'm like looking for something, I don't know how to.
Yeah. So, well, I think like
Arduino.cc playground.
Yeah.
So on the Arduino.cc website, there is an examples and a learning section and a playground link underneath that. And all of the different libraries people have written that think might be useful to other people are just going to put up there for you to play with.
But you have to go through and read them all to see what they're doing.
You do actually, and with the timer, for instance, the timer, there's about a dozen different timer libraries there, and they're all subtly different. We chose Simple Timer because, well, it's a simple timer, but they get ridiculously complex, and you do have to kind of go through and figure out which one's going to meet your needs best. Or which one you want to use as a starting point to rewrite and do what you want.
Can you say how to get one? Your repository?
I basically just Googled Simple Time Arduino, and then the first link was GitHub, and then there's a zip, download the zip, and then you can go into this program, and it is include library, and then add zip library, .zip library, and then it should work.
He pulled it from the GitHub repository, but it's also listed on Playground and Arduino.cc.
Right. Yeah. And then when it's in the library folder, it's going to be down here at the bottom. And then you can just click it to include it in your program. So here I'm declaring what pins I use. So LED pin, so to test what I did, I used an LED instead of the relay because it was attached to the dust filter. So just for testing, I used an LED. That's why it's called LED. That actually means that signal is going to the relay. We've got an input pin, button pin, and then a bunch of other variables. Yeah.
At some point in here, talk about the problem we had with the relay too, because that was quite interesting, and it stuck me up. Well, I guess you're right. There were multiple ones. So you think that when you use the relay, it's just like a switch, that you give the low voltage signal and it's a DC input, and the high voltage that turns on. When it's not turned on the low voltage, you just get nothing, no connectivity across the high voltage terminals. In fact, that's not the case. even when you're not feeding power to the relay, you still see 120 volts with the multimeter across the high voltage side of the relay, but its current is amped down to essentially zero. So when you feed the DC signal to the relay, it's the current capability of the AC side that amps up. And so we were stuck for quite a while testing with the multimeter, going, why isn't the relay working? When we turn the power off, it still has connectivity. And so yeah, that totally.
Right.
That's not for real.
So was there something resistance in there? What was the?
Well, so it's actually a more complex circuit than I thought, because it's trying to
It
do.
wasn't just a physical relay.
It's not just a physical relay. It actually has a set of rectifier diodes in there and a bit of a circuit through an IC. So it's isolated from the DC side and current limiting on the AC side. So, yeah. It was much more complex than I thought it was.
Yeah, I had troubles understanding what was going on as well. But once we connected it to once we put it to the load, we figured out that it was actually working, which was nice. So I have here two functions, and basically, so these are so it's a fan state, we'll set it to 0, and button state, we'll set it to 0, and basically we'll go to these functions once the timer is up. So I'll explain that a bit more in a second.
Actually, I'm going to ask you to just take a step back again, because this is the first time we've introduced the idea of a function in class. We've done loops, and we have the setup loop and the main loop that you've seen in the code here before. But this is the first idea of a function, which is called from anywhere else in the program, executes that little bit of code inside the named function, and then comes back to your program exactly where you called it from.
I've seen a couple of sketches that have that void function, either before the void loop was set up, or sometimes after the void loop. It doesn't really matter where it is.
It really doesn't matter where it is. It's going to go through during the compilation step, where you see when you hit the upload button, you get that says compiling script, and then it chugs along for a while, and it says uploading. That compilation step is actually a multiple pass compilation step. And so the first pass is to go through and find where all the function names are, stub them out, and then it does a second pass compile to actually build the code out of it. The other thing that is worth describing here is what that void actually means. That void is declaring a function that returns no value. And so when Armand calls fan off, it doesn't clear it, but if that is read int fan off, and the last statement in this function was return fan state, then instead of using a global variable fan state, which everything in the program can see, it would have returned fan state just as the return value of the function. And so a void just means that there's nothing returned from the function. There's no value coming back from running this function. And the way that Armand set this program up with the variables at the top declares all of the variables as global. In a small sketch in an Arduino program, this is a very appropriate thing to do, because then you can see those variables from anywhere. If you're talking about a more complex project, global variables are generally a bad thing to be avoided. And this is primarily because you get side effects of changing them one place and having them used in another place, and it makes the whole program feel more complicated. But in a simple sketch like this, where you're really just kind of doing one thing, then global variables are probably the easiest thing to explain how to use.
Okay. Yeah, do I need to say anything more about functions? Does anyone have questions about functions at all? Or should we talk about it a bit more later? I'll go into the void setup now. I'm pretty sure everyone's familiar with the pin mode. So LED, pin, output, input pin, and button pin. So that's the sensor and that's the button. These two lines here are specific to the simple timer library, and what this allows you to do is set your time intervals. So I put timer, which I declared up here. So simple timer, every time I call simple timer, it's going to be labeled as timer. And then I go dot, and set interval is a function within that library, which lets you set the time interval you want. So I'm setting it to 300,000, which is 5 minutes, and 600,000, which is 10 minutes. And then the function that I want it to go to once that timer is up. So yeah, so every time 5 minutes passes, I want it, or I think that's how it works. Yeah, I want it to jump up to the function fan off. So you see the function up here, fan off. It's just a calling method. Serial begin allows me to put output statements so I can see if the code is running correctly.
On the serial mode.
On the serial monitor, yeah, that's correct. Because that, like, if you see here, like, I have a fan off function just to know when it's going there, and also here, and other spots in my code. So then the void loop timer.run will start the timers. You need that statement. They explain it in the library, like on the website, playground.cc. They explain it. That you need that statement to get the timers to go. And then first thing that we're doing in the loop is we're seeing if there's motion. So I'm saying motion equals and then digital read input pin. And I'm also seeing if the button has been pressed. And then what we do is we go into a couple if statements. So if there's motion and the button has not been pressed, we'll turn the fan state to 1. And fan state to 1. Yeah, so we'll turn it to 1. Basically, if we want it on, it's going to be 1. If we don't want it on, it's going to be 0.
Yes, Emily, something I remember mentioning the first night or last week is the relation between true and false and 1 and 0. It would be equally fine to say fan state equals true in here.
Right. It's a good thing to point out. And then I just have a timer reset, which I commented out for some reason. That shouldn't be commented. Okay. So since the timers are starting up here, and then we detect motion, we want it to restart the fan set timer here. So basically, once we have motion, we tell the program to start timing 5 minutes, and then it will count 5 minutes or whatever you decide the timer interval is. The
Another way of expressing this is that we'll run for 5 minutes after we got last bit.
Right. Yeah, it's true. Then we go into the next if statement. So if we don't go into the first one, the next one would be, is the button pressed? So if button equals 1 or true, we'll turn the fan off. That's why it says fan state equals 0. We'll turn the button state on. And that's commented out. It should be. Which will then we'll set the timer for 10 minutes for the button. So now the fan is off and it's going to be off for 10 minutes. And yeah. So those are our 2 if statements. So if there's motion and no button's pressed, and if the button is pressed, then we do 2 different things. And then the last statement here is, so if there's motion, fan state is 1. That means we want it on. So this is what's turning it on. So if fan state equals 1, we set LED pin to high, which is setting the relay to high, which is turning on the high voltage side of things, the AC side of things, which turns on the dust filter. Else, LED pin low. So let's see. So we'll loop through this constantly, and yeah. So for example, say we start the program, and there is motion. We're going to set fan state to 1, and then we're going to restart the timer, and then we're going to go down here, and it's this if statement because we have fan state equal to 1. We're going to turn on the dust filter, and then it's going to keep looping. Once the timer has hit 5 minutes, it's going to jump into, because of these statements here, once it's hit 5 minutes, it's going to jump into our function, void fan off, and we're gonna say fan state equals 0. And then we'll go back into our loop. And so now fan state is equal to 0. We're gonna go down here, if fan state equals 1, it's not 1 anymore. It's gonna go else, LED pin low. So that's just an example of what could happen in this program.
One thing to be a little bit cautious of as you're using something like simple timer, right, is that at the instant that that 5 minutes is done, that timer is going to kick it off and throw it to that function, regardless of where else in your program loop it is right then. And so if you have a point where your function could cause an unintended side effect, depending on where it was in your program that it got called, you have to be really careful of that. And so this is why try and put the places that actually control fan state, turning on and off the fan, for instance, all in one place in here. And in this case, it doesn't really matter because the loop is running constantly. There's nowhere that's blocking. And if on one round it jumps up to turn the fan off when it's in the middle of the button equals 1 statement, well, it doesn't matter because the next loop is going to be just a few microseconds after that. But if you have a main program loop that has some delays in there or waits for user input or something like that, so it's not a rapidly cycling loop like this, you can find that timers really are very hard to debug in that process because it pops out to that timer from an unidentified place.
Okay. Yeah.
Can I just ask,
Yeah.
because you're going from a battery to the 120-volt power plug.
Yeah.
What's powering the Arduino?
So what's happening here, is there's a voltage regulator. So basically, we have the Arduino, a relay, and a voltage regulator. So basically, what it does is it'll take power from the plug and it'll convert it from AC to DC to power the board.
Right.
And then from there, we do everything else.
Okay,
Yeah.
I was trying to figure out.
Yeah, exactly. Yeah.
Can you explain, I'm kind of confused on how the relay works. So how do you go from the 5 volts or 3 volts, whatever, from the Arduino to the relay? Like how does that conversion happen?
Okay, yeah. So basically, it's just a switch. So when you plug into the wall, so basically you'll get power from the wall, and then there will be the relay, which is gonna cut the circuit, and then there's gonna be the other side of the circuit that's gonna go to the motor.
Right.
So do you kind of see what I'm saying? So the relay is just a switch within the AC side of things.
Right. Okay.
So basically it's open, which means that there's no electricity running through the AC side.
Right.
Once we put 5 volts DC onto the relay, that will close the circuit, which will turn on the motor.
Okay.
So basically, it's a switch that we can control with 5 volts DC.
Okay. So that relay specifically responds to 5 volts DC, or can it be any?
There's a range on it, so it depends on which one you buy. The one that we have in there,
Yeah.
it ranges from 3 to 24 volts DC.
Okay, and that will cause the switch to close.
Yeah, exactly. So anything outside of that range will not respond.
Okay. And then it completes the circuit. And then
Exactly. Yeah. So we have like the DC side of things where we can control the circuit using code, and then the AC side of things is just kind of simple. It's just into the wall, through this switch, and then to the motor.
Right.
Yeah.
So does the relay act a bit like a transformer in that sense? It transforms the alternating current into the DC?
No. There is an AC to DC converter, which powers the board.
Mhm.
But this, the relay is just a switch. It's just like an on-off switch. Yeah. I don't know if that is that clear or.
The difference here, is that a transformer is going to be taking a single voltage source and turning it into a different voltage. Here we've got two independent voltages going on. We've got DC, which is coming originally from the AC line, but it's going through a regulator circuit to bring it into the DC. And the AC line we want to have nothing to do with inside of our low power components. And so having an isolated system through the relay is better than having a coupled system through a transformer.
transform onto it.
So this is just like the way I think of it is just like I literally think of it as like a physical switch, but now we're able to control it automatically.
One thing that we did do in this that y'all should be aware of as a potential concern is National Electrical Code. It stipulates that if you have high voltage circuits and low voltage circuits, that they be separated by a grounded plate. So you can't have your high voltage circuit contact your low voltage circuit if the screw comes loose or something like that. And I don't actually know anybody who does that who isn't producing things commercially. So be careful of that. Make sure your screws are tight. Make sure you're connected properly. And if you really want to install this forever in your house and have an inspector come through, make sure you've got a grounded metal plate between the two halves of the circuit.
Can you just route it to the copper wires in your house?
Yeah, absolutely, yeah. So this is actually this box on the wall that the power plug is coming out of. The center screw here that goes into that box is tied to the ground plug in the plug. So that is meaning that if there's ever a short circuit or anything, you power the wrong place, it'll pop through ground and isolate it. And so it will never make the metal part of the box electrified for you to touch and get shocked on. And so the same thing is true if you're running a plate across the center of a relay to separate the low voltage side and the high voltage side, that then if a high voltage lead touched that grounded plate, it would pop a breaker, but it wouldn't leave an electrified box for you to touch and get shocked by.
I don't know if do we have any more questions about what I did or
And walk in the wood shop and admire and go, except it's still on the ground.
It's
We
still
haven't
on the
looked into
ground.
this guy yet.
Yeah.
But
we can open it up.
it's true.
Yeah.
Cool. Thanks, Emma.
No worries. Yeah, cool.
All right, cool. So the next thing I wanted to do, and Andy, I might ask you to camera zoom in on Zach for this part, if you can shift over. Next thing I'm going to do is have Zach give a little bit of a soldering demo. A few things that I've asked him to talk about soldering and desoldering and irons, and we've got a couple soldering stations around that after he gives a demo, I'll talk about some things that it would like you to solve for the project for the LEDs, and we can go and practice some of this there. Anyway, Zach.
Okay, so once it's turned on, we pull the soldering iron out of the two like that, and then before you want to solder anything, you want to get a bit of solder and then you put that whatever you're going to solder. And then tin these, I put in the soldering iron on the wire, and then the solder tube, and then use the same other wire.
And why are you getting them?
So they stick together when you're actually soldering.
So you put the wire, you put the solder on the wire, not on the solder.
Yeah. And then so there it is. So
Why do you like it better now than you did before?
a minute ago, if the wires weren't actually touching, there was a cap of solder in between them, so it was a pretty neat trick. And if the solder cools too rapidly, it's called a cold joint, so it's a lot weaker, and you can tell if it's not very shiny, the joint. It's like a dull crystal. Yeah. And then for removing solder, you can either use a braid or vacuum. Yeah. prefer the vacuum sucker. So you heat it up and then do that when you have the sucker on
Do that again, like, there's a circuit board of the, transistor something, and I just want to pull it off. That's what I do.
but when you're removing something off of the board, I prefer the braid. So you would kind of place the braid over the joint and then put that on top of it. And then the braid sucks up the solder and then something.
Okay, so then you just, I can rip it off.
So you can't use that solder again, it just stays on the.
Yeah.
And then just pops it over.
Yeah, and then you hit the stuff and use
So try to use it too.
yeah.
What about the stuff that goes in the sucker?
So see, it's, when you press the buttons and it's kind
Oh, okay, so it hardens inside the sucker, then it just rolls around.
Yeah.
One of the problems you'll often have when you're desoldering things off of a board is that if it's a chip, for instance, and has 8 pins, you're never going to be able to get all 8 pins of those clear at once, and you'll have little bits of solder, and it's really kind of laborious. My soldering set over on that side over there, and one of our makerspace usually has this as well, has a heat gun attached with it. And so that is actually a desoldering gun because it'll heat all of the pins up so you can pull the chip off all at once. And this is great, it makes it a lot easier, but if you are using that, be really careful about not overheating the chip if you want to reuse it. It's a lot harder to control the heat that's coming off a heat gun than it is individual solderings.
So I guess that
And
means.
figures are getting it on. Is it just surprised the chip doesn't work? Or?
It sometimes is that there are some guidelines that if you're soldering discrete components, say you're soldering on a resistor onto a board, well, you can probably put the soldering iron on there for 30 seconds and it's not going to hurt anything. That resistor is pretty tough. If you're soldering on an IC, a sensitive chip using the straps for static protection that Andrew is sitting over with down then. It's also probably very heat sensitive, time you create a cold solder joint that looks dull and gray and not shiny. On the other side, you don't want to leave it there for 10 or 15 seconds and fry the chip on it. And so it's kind of this balancing time between the two. When they actually do soldering of the surface mount boards, like the Arduino board they've been using, or like one of the Raspberry Pis, they've got a temperature profile for each of the chips that go on here that specifies the ramp time, how long it can stay at a maximum of the solder, and how quickly it has to cool back down. And so this is all in the data sheet for the individual chips, and they have to do some calculations to see what the appropriate solder times are. Of course, when we're doing things by hand soldering, we don't have any of that information. It's kind of seat of the pants stuff. And so the rule of thumb is that on chips, 7 seconds is your absolute maximum. If you've been fiddling around holding the soldering iron on the chip lead for more than 7 seconds, take it off, reposition, get it positioned better so you don't have to hold it that long.
Would you ever twist the ends and then solder? Or does that not?
Yes.
Anything?
And I'm going to be showing an example here in just a minute of how I did the soldering for the LED circuit. I actually found that to get 3 sets of wires together, it was easiest to clip the wires, strip them, put them so that they're the same height, throw a piece of electrical tape around it so they don't shift around, twist those wires together, twist my 3rd pair onto it, and then rather than doing it in the air like Zach was there, the reason there are boards at the soldering station is that when you're doing wires, I find it easier to press the iron down on those 3 wires together, put the solder on it, and let it nice and melt in, then hold it and let it off. And mostly it's because I came to the helping hands late in my life and haven't begun to rely on them quite as much.
I wonder if there might be some little crimping piece that you could, if you're joining 2 wires, some little metal crimp that you could put on there.
The bigger
solder
wires.
the whole thing.
The bigger wires, there's for sure.
Yeah.
And then you just solder.
Right. For this size wire, there generally is not. Crimping is generally not effective on very, very tiny wires. Maybe Zach, you can talk a little bit about what happens when you come into makerspace and the soldering iron is just totally dirty and you can't get it to melt solder very well. What do you do?
In that case, you take a bit of water, wet the sponge, and then just load that. And when you're doing solder joints like this, every 10 or so joints, yeah, get any solder residue on the tip off of it.
If it's really, really messed up and a little bit of water on the tip doesn't do it, the other thing that I'll often do, well, not often, but I have to do it once in a while around here, our irons get pretty abused at times, is in the wood shop, there's a great big box of sandpaper, and there's memory paper in there. And with the iron on, because you only want to take off the surface layers of solder, you take the emery cloth and just quickly wipe it around. And of course, you're doing it quickly because if you hold your hand there, you're going to burn yourself. But if you do it with the iron off, then you have got to scrub and scrub and scrub more, and you actually wear down the tip a great deal. Whereas if you do it quickly with it on, you're able to get it clean a lot more easily.
I just got a soldering iron, and I've got the sponge, but I also have this kind of curly Q metal thing.
Yep.
You can, when it gets really mucked up, you're supposed to just rub it in there. It kind of looks like a Brillo pad or something like that. You can scrub past.
Except importantly, it's a copper Brillo pad, which means it's much softer than the tip of the soldering iron, so you should want to actually be wearing the way the soldering iron goes the way off of it. Do you want to talk a little bit about rosin? What's rosin and when do you use it?
So some, when you're soldering, some things are really difficult to connect to each other. So you use rosin, which is a material that, when heated, becomes corrosive, so that it can easily merge the two things that you're soldering together. I don't have any right now, but
Should be a core of the solder.
yeah.
This one is not, but this is a rosin core solder.
So is this the same as flux?
Yes, that's a rosin. Rosin and flux are the same thing. Yep.
This one has the core.
Does it? Okay, great. Yeah, the thicker ones generally do. The very fine solder that Zach's using there, I think, is not a rosin core solder.
So you stick the two in the water and the flux is rosin.
Yes, smoking is the rosin burning away.
Once they're like that, before you start, you take that. And
Well, maybe it is a
some of
rosin.
them are like cans, and
Oh,
are a
jeez.
little big. So you can mask too thick and put it on that water.
It does not say it's a rosin core solder. It's also a lead solder, which Barrett's been talking about a little bit. Well, exactly, and that's what this is for. I don't use them very religiously, and probably I should, but the charcoal fan will pull the organic vapors and leads and everything out of the air, so it is a good thing to use. If you're soldering and desoldering boards that are certified for use in the European Union, they're all done with non-lead solders, and what this means is you're going to have to get to a bit higher temperatures to pull the components off. And it's kind of a pain to get good results. I really prefer a leaded solder for hand work, but just be aware that if you're working on a board and just wondering why the heck my normal iron settings aren't getting a chip off, it's probably because the non-lead solders are higher temperature solders.
So they're tin and rubber.
I don't actually know.
Tin, copper, silver, there's a bunch of different.
Okay. General, please.
Soldering irons. I brought one that I got from Canadian Tire or whatever, but it's just got one setting, right? And it's-
Yep.
Maybe that's not as good as this kind that you can adjust.
Not as good, but perfectly usable for this kind of application. 90% of the time you're soldering will be in exactly the same heat setting, and you pick one that works for you, and you just stick at that. My iron over here has a numerical readout. I really like soldering at about 415 degrees. that seems to be kind of the sweet spot for me between melting the solder nicely and not overheating things in a reasonable amount of time. If you have a single setting, you don't actually really know what that temperature is, but you learn to work with it and figure that setting out.
Go grab your Arduino as a temperature sensor.
Hey, there you go.
It's true. Detect that high temperature.
Well, maybe. Might as well. They might not go high.
Yes, it was one of the orders.
One thing that you might want to note is that the animatronics videos on Stan Winston, so the guy there, Dave, something like that.
Oh, that's right.
He does a demonstration of soldering.
Yep.
That's quite very similar to what's out there. And should talk about the soldering out here, and pre-tinning.
Yeah.
Did as well.
Yeah. Yeah, good. I'm glad you're watching this. Very
They're pretty good too. They're very well spoken to the people. I'm watching the Dave guy, and then I started watching another guy doing.
Oh, right, yeah.
So he's going through all of the basics, wiring, how you solder LEDs together.
Yeah.
So well worth the time.
Yeah. Yeah, I'm gonna go into a section here in a minute. Are people watching? Okay. Yeah, no, it's fine. I just wanted to see the demo for that. I'll step back.
I think it's from the top.
Could you keep half an eye on if people are asking questions on the, we've got 3 people online now, or possibly, I think 2.
Yeah. Yeah, so on the other side of the board, you usually see some silver or metallic color when it steps off the solder. And there's usually a bit less smoke from the when the solder's hot. So
The idea behind this is that the braid is able to suck up more of the solder because it's porous and stranded, whereas you've got a single piece of wire into a hole that it won't suck the solder quite as well. It really is. Yes.
yeah. Usually,
That's what I really like about the deep pin approach is that it doesn't do that all solder at the same time. No, it's sitting there. It is just like a hot air gun. Yeah. The only thing different about a hot air gun than you might have gotten into the hardware store is that this has the digital readout because you want to make very, very certain that you don't fry the shit.
A lot of things now, I think they actually put on boards so that shields.
Correct.
Now, when you think stuff out, how much do you have to worry about leaving John too long on other people that you might just take into
yeah, pretty much. But if it's something like a transistor that's generally too fast, not really something you have to worry about. It does break in 5 or 15 minutes.
Yeah, some things you might want to really recycle with others.
Yeah, regular tools.
The same thing with the transistors also is they have a heat sink on them because they actually generate a thermal heat themselves, and so they're also able to dissipate heat better. We'll be using transistors in there.
Yeah, so I could probably use pliers to get it off the most of this stuff.
Yeah, good to look.
go grab a huge long length of the orange wire that's on the end of the wire spool. The wire spool closest to the yellow strands on the wall. Just spool out maybe 10 feet of the orange wire.
Sure.
Thanks. That is Andrew's static card. Particularly with ICs, they can be static damaged, yeah, it's better under risk. You don't generate static electricity in that. Because it's using the ground plug. It's one that I don't tend to mess with the Arduino. They're really robust board. Talking about memory circuits on that computer or running some minor ICs. They do weird things. And if I were more paranoid, I would, yeah. Fantastic.
So how do you tell what this thing actually is?
Aha! You are the lead in to the next part of the discussion tonight. Cool. Thanks a lot. That was great. So the next part of the discussion tonight is I've taken the LED strip that you'll have in your kits and have wired it up, but the LEDs have to run off of 12 volts. Thanks a lot. The LEDs have to run off of 12 volts, and the Arduino only pumps out 5 volts. The other thing is that if you use the full meter on your LED strip, you've got to draw about an amp of current, and your Arduino pins can put out, I'll have to look this up again, but it's definitely in some number of milliamps range. You can't pull an amp of power out of any of the Arduino pins. And so the essential component that allows us to do that is the transistor that's in here. So in the circuit, and I'll show you a schematic on screen as soon as I hook my computer back up here in a second. But the circuit that allows us to do that is the grounds are all connected on the one side of the transistor. And then the emitter and the collector are the other 2 pins that are there. And so we feed our signal into the emitter, and then that allows the collector to drive the power requirements. Essentially, the relay we talked about a minute ago in the dust filter application, that is almost what a transistor is doing in this circuit. And then you've got a control signal going onto the 1 pin, and then the other 2 pins of the transistor are allowing a high current signal to transfer through it without ever feeding back through that control pin. And so on these transistors, I'm going to hand you a few of them here in just a moment. Well, let me actually do that now so you can start looking at them. If you want to grab 3 of these, I'll be passing them around. Get those here. So the transistor, there's a data sheet on it. I should plug my computer in before I do this so I can actually point to these things further than. Hold on. Is it 1 transistor? 3 of them, please. 1 for each color on the LED strip. Okay. So that's a lot easier to see. So on the transistors, hold them so that the black part is towards you, and yeah, then that'll line up the same way that it does here. And we've got this one being powered from the 9-volt on the Arduino. That's not actually what we're going to be doing because we have actually a 12-volt requirement. A 12-volt requirement on this rather than 9 volts, and we want to be able to use the whole meter of LEDs here to get it bright and as big as possible. So looking at the transistor, we've got the ground pin, and the center pin is where the current is going to flow between the center pin and the ground pin. And then the signal goes in on the left side pin. So the ST is what I on this particular pin package remember as signal because it's labeled the ST for the manufacturer of this particular transistor. What we're going to be doing is taking the LED strip that I have here, and some of you have an end on that, and most of you do not. If you do have the end, you're unlucky because it means that you won't get the soldering practice that the rest of the people in here get. Or cut it off and use a smaller piece. But if you do have an end, you're free to actually just use that directly for right now if you want. But it's a bit of a different trick to soldering on these LED strips. So I'll actually give a bit of a demo here in a moment, and then also talk a little bit more about what I did with the power supply to enable this. But in just a minute, we get some soldering practice. And the circuit we're going to wire up, you can see on the LED strips that we have a plus 12, G, R, and a B. These are analog LED strips. If we've gotten the Adafruit order in tonight, Mark, I think you got a bunch of the digital LEDs, which are infinitely cooler in some ways. They cost more and hook up differently. You can't use them in a high power circuit quite as easily necessarily. Yes, they have some disadvantages, but you can individually control the LEDs. Whereas this strip, the whole strip is doing the same thing at once because it is an analog strip. We're feeding a signal into the different color channels. The RGB color channels here are taking a signal that controls how bright it is. And so you can see that my circuit here is going through a fade, fading from one color to another color. Basically varying the brightness of individual colors there based on the RGB values. This is using 3 pins on your Arduino board, pin 3, pin 5, and pin 6. That you'll notice there's a little squiggle next to those pins that says PWM. Squint and see a PWM on there. What the PWM means is that you are feeding a digital signal, but you're controlling the amount of time that signal is on within any given cycle. And it's using that PWM value as an indicator to the RGB LEDs as to how bright you want that particular color channel to be in the LED at that point. You also use PWM a lot for motor control. So as we start talking about motors here in another week or two, we're going to be coming back to PWM because that's what you're using to control the speed of your motors. In fact, in some of the servo positioning, one of the servo mechanisms is also use PWM to control the angle of that. So PWM is a really useful encoding technique that the Arduino makes pretty much simplistic for us. We don't have to worry about the timing guts to get a PWM signal out. We just have to know it's a PWM controlled output and use the libraries to put that out for us. I'll talk about the code side of this a little bit more in just a minute, but I'd like to get people actually soldering and getting their hands busy with the irons that were around. So the next thing I'm going to talk about here is the power supply modifications that I made. Because again, I'm not coming from plus 12 to the Arduino board directly. Instead, I am going to the power supply. Although it occurs to me that I didn't actually check that. I may have done something dumb to my power supply. Let me see. I'm used to working on one of the other boards that doesn't have the V in there. And if I actually have 12 volts out of my board, I'm going to be kind of embarrassed. Ha! What do you know? I do have it. So, yeah, why cut up your power supply tonight? Let's focus on soldering the LEDs and not soldering the power supply modification that I made. I'll scratch my head on that one. So what I did with my power supply, and at some point you may end up doing something similar just to get the wires to be long enough to do what you want in your project, but there's no reason to do right now, is I had cut the power supply wire and soldered 2 new wires to that so I could extend them directly to my expansion board. And the advantage this had for me is that then the positive current path never goes through the Arduino board. And so I wasn't at all worried about frying the Arduino board. There's a pin called VIN on the Arduino board, though, that's right at the base of the power pins on the same side as the power supply there. And that VIN is actually exposing the supply voltage of the Arduino. Now, one thing to keep in mind is that if you're plugged into the 12-volt supply, that's great. That's what you'll see on the VIN pin. If you're instead plugged into the USB port, driving this off the computer like we have been so far, you won't see 12 volts there. You'll see only 5 volts there because that's what the USB supplies. And that's actually the base required power for the Arduino is that 5 volts. And so if you plug your LED strips in, they won't even light under 5 volts because it's a string of 3 LEDs. So don't expect that to work when you're actually plugged into the USB port. So the way that we'll do it for this project tonight is we'll plug into the USB port, we'll download the code, we'll unplug from the USB port and plug the external power supply in, and then do the rest of the circuit from there. Uh-oh. Do you need to borrow a power supply? Oh, I've got one you can borrow. Particularly if we're no longer cutting them up, you're welcome to borrow it. Cool. So why don't we get the soldering side of this figured out first? How many people need to put things onto an LED strip? Great, you guys are all like 4 lucky people. Oh, that's the lucky side because you get to learn how to do more soldering. Let's get up. We've got one station over here that has the magnifying lens on it. I find this really useful because I'm going to get told and going blind. But I set my stuff up under that so I can just see more clearly what it is that I'm working on. And then we've got another. Oh, it's already turned on. Excellent. Another iron over here that's turned on, so we can get 2 stations here. We've got the station that Zachary is using that has the helping hands. And then I've got another set of helping hands over here, and we can plug that iron in. It does not. If there's one that has the little silver bits of solder, that's going to be the easier one to use. Okay, great. Then I would want to right. Oh, yeah,
There's one point below there.
Everyone knows your stuff plugged into it.
Yeah.
Yeah, it should fit.
No.
We'll take some.
I already have the pins, so that's.
Yeah, absolutely. You're also welcome to solder onto the opposite side from your pins if you want, rather than cutting them off. It doesn't matter which end you put the power into on these.
Oh, okay. So I just cut off here. Right?
Sure, if you just want to use one strip, that's fine too.
Yeah.
Since then.
Great.
So,
Yeah, you don't need that much. But you
Was this for crossing
where's the wire we connected?
Well, so you're mostly limited by the current carry is not the package that your transistor is in. And yeah, so these guys are fairly beefy. I think they can move up to and so nothing we're doing here is going to need changing. It's basically relying on the fact that the semiconductor nature of these two pins is altered by the input pin. So it's basically the thickness of that layer that controls the total amount of current and the dissipation through the heatsink to not actually burn out the substrate material. And so, yeah, I guess I can see the situation where you need to change that.
You don't want to carry on with that.
It's also good for straightening the ends.
It's like,
Oh,
I'm
okay,
making it
yeah.
look like,
It's great for coverage. Trying to split the ends.
I see two wire cutters. Oh, I think I've got it here. Are the blue lines in use? Oh, there. Thanks.
there you go.
Okay. So we're getting some pieces of wire and then we're soldering them onto here so that we can then plug them into the breadboard in that type of circuit.
Okay.
And so
Do you want to color?
in an ideal world, but I've been in a perfect world. We could go find the different colors. I wasn't organized enough for that.
Okay.
So I actually have been putting pieces of electrical tape on them to identify the plus one, and then the other three colors used kind of where they're attached. But the only one that we met and mess up is the one that's carrying the current, so the plus one. Right. And there should be more wires floating.
Over there.
Oh, excellent.
You know, the cutters on the wire.
Collaborate.
You don't touch it, you put it near.
Depends on how much distance you want between your board and the LED. There'll have to be plenty. I mean, I've got a little bitty short wires, but yeah. Oops. These things lock around. Okay, so let's split that in three. And, oh, you want 4 on 3.
We're still warm with it. No. It'll be warm
It's
enough.
only gonna be so long that lasts.
So when you actually get to the point of soldering, we've got the tin stuff. I would then tin that in as well. Okay, perfect. Yeah, you're on. Oh, jumping button.
What's more?
I'm up here now.
In the way rather than helpful?
Well, yeah, I see if I can actually numbers first before
If I want to use my laptop instead of this, can I unplug?
Yeah, by all means.
I think it's right.
I'd like the Raspberry Pi power source. If you're not going to use right now, feel free to unplug it. Yeah, totally.
How do I connect to the?
If you connect to, you have three choices. VITP open is just an open access point. Makerspace is make stuff, and BioBit. We'll see if we can find Makerspace first. Or one of those two. They're just there as computers to program the Arduinos from. And people have been, I thought more people were going to use the Pis than are using laptops, but I think we've only got 2 or 3 people actually using the Pis.
I see. As of now. Yeah. Actually, it's stay with it. It should.
Oh, geez. That was just looking. Yeah.
We'll talk about the code of your engineers and that will make it sort of kind of less of your cut this all together. Yeah, make stuff all lowercase is the method. I think we'll double check. Oh, the only issue that you would think about a little bit is with the end that's going into your breadboard. You want to make sure that you pretend that it's very thin, because
Use the right end.
yeah, use the proper end. Exactly.
Let me find you a
Scissors.
That technique.
you have more solder.
Yeah.
Someone had the rosin cord solder that,
Here it is.
okay.
This thing's gonna go in the board. It's gonna be stiffered up.
I don't have a sponge for over there, so I was using
Down on the wire and then solder on it.
Okay.
So.
Yeah, either end is fine. If you use that end, it's pretty fine. If you use this end, you have to. So if we look at what happens when you solder a piece of wire to an unpinned end, you've got to melt solder it simultaneously onto this, and holding them together. And that's a fair amount to ask. So if you take a little bit of solder, dab it on there, and then dab it on there, dab it on there. And then take this, a little bit of solder, and dab it on there. Then you don't actually have to get any more solder out of it. You put it together, you keep the two together. So pre-tinning just makes it a whole lot easier to put the parts together.
Okay. And then when we put it together, we basically want this to overlap on this.
Yeah, exactly. And I would actually encourage you to cut these pretty short. I mean, maybe even to there or so, because then the part that is connected doesn't leave enough to actually cross into the other ones when it gets pulled through.
Oh, yeah.
Go right flush to it, basically. And over this, you have.
Okay. And then the other end,
Yeah, I usually let that go ahead and warm up so it gets to the right temperature.
and then for the other end, it goes into the red board. You have to do anything.
Don't have to do anything to it. I generally just kind of twist it together and stick it in. And that's actually why I have the orange wires, because it's thicker than the wire we actually need for this, but it fits in the red board.
That's how I did it. It's a drop.
Oh, ow! Oh, ouch!
But luckily, it's not there.
Yeah. Right. And I would encourage you to actually do the solder. Your call. I find the piece of wood easier. Zach tends to like the helping hand style. Also, go back in there.
Which one of these should I just on?
If this, it is a Windows machine, just the Windows installer is great.
Man. First time probably within 30 years or something. The others went a long time.
Yeah, that's,
Yeah,
I would actually use it.
yeah.
And it's just really tricky to touch and drag them so you get these connections.
Oh, yeah.
Just have that solder.
I'll get there at some point when I have an actual breadboard to solder. I suppose this is what this is all for.
Yes, that's
Kind
good.
of ready to go for some kind of stuff. It's all set up.
when we're actually going to be starting this on, if you've got walls, if you've got walls, anything like that, pull against each other, short circuit, I would sleep with it, and try and make the platform start, I mean, just.
What's that? Probably.
Yeah. It's I would do the
Whole length of it?
The main thing going on for is the controllable temperature, so, the West Virginia ones are about $80, the non-controllable ones are but the controllable temperature is really good.
Yeah. Okay.
Okay. So all 8 in?
I knew.
Oh, right, yeah. Right, no, I've got a couple of those as well, I didn't actually bother pulling them out for today, but, I might also point out, that, when this is actually connected, you want to have the plastic snubbed out pretty much exactly close to the end, because otherwise, when it pulls the wires in across the channel, but if your solder is plastic is right put it up, it's very nice. You won't have room for it to
You don't have any.
so shortening those wires down so that it's
That's what Derek was just saying. The parts that are going to be attached to the script should be a much shorter.
Okay, so this is okay on the normal.
Are you just waiting for an
Yeah.
So, so can it close to the, yeah, exactly.
Hey there.
Absolutely.
So we do it at the poll and get some color.
Oh, sure. So we've got questions. One of the easiest is just to hold the
Okay. So it's always, this is on the opposite
no, it's actually hold the iron to the wire, and then when the wire gets hot enough, dial a piece of solder onto it. No, with the iron still there. And yeah, so I usually actually just test the solder to the very tip of the iron, and I let it melt down to the wire.
Yeah.
That's not needed. It's enough to just.
So you start learning.
Yeah.
So say you have the two pin from the solder version.
Yeah.
Just melt it.
Derek? So you may have actually taken my kind of very short example, a little too short. But what I tend to try and do with it is with the iron, make sure that it's
Sucking off of
or trying to have maybe
But you guys have flux there.
and I held that down for a long time for itself.
It should be as long as you're not, burning it all off. Like going really slowly.
So how short is it?
So how do you know there's like enough?
Basically, if it's enough to hold the wires together, it's enough on there. You've got the excess of solder on this side, and you've got slight excess on that side. So when you hold things together, it's just going to melt together. And make it.
Yeah, I couldn't get it set up.
So the case where we're actually connecting, how is
Working on it.
Right. So this is a little bit iffy, and it's always kind of a very balanced.
It's
What I do is
here's
I would hold that together, this guy
yeah, this one.
Specifically to use it on.
And I suspect that some point they'll be the one that's not shining.
So you melted it, you lifted it.
I did, only to make it faster, and put it on together. It's, the other option was to just lay the wire onto it and then take the solder there.
Yeah, it's pretty simple.
And it's only,
It's not very much.
Yeah.
So let's just go on. Oh, I see.
Yeah, I'm going
It is doing a bit of throbbing, but it's not.
This relay that totally 610.
Yeah, see some lights like now.
It's only, it doesn't seem to be cycling through.
Yes.
It is, kind of. Did you just grab the code off of the,
Yeah, I did get.
They get that,
and then
yeah,
like
okay.
RGB that I know.
Yeah, so that should be the same code that's cycling colors up online. And it kind of slowly weaves through the, you're just kind of going down and down, aren't you? Good, great. Did you have a chance to fill out the text form things? Tyler's coming right after class to detection.
Yeah, I kind of overstretched things and all things are kind of touching.
Oh, okay.
I need to keep those.
I guess not. If you don't have it, then I guess not.
Yeah, why?
Yeah, I need to-
So I guess no, that's fine. I guess the key thing is the deductions that are on there. Do you think you want to get a minimum deduction level?
It's all around here.
Then we'll do the deductions at the minimum, and double check.
There's some reason.
I know.
Honestly, I don't.
Okay, cool, no, that's great.
Traditional ways.
Yes, we can, we did.
Okay,
I'm
then
still
I think
behind.
that means that we can go in at the.
Really?
level.
Oh, yeah.
I mean, it's fantastic.
Yeah.
It's all good.
Cool, all right, great, thanks.
Running the same
Yes,
software? I'm a little skeptical, but I'm just thrilled.
All right, okay, cool.
There's that one. It's getting it.
Yeah.
It's kind of weird that Gravity's, we, like,
Like that, yeah?
In process.
Yeah.
Well, I think we kind of.
like, I don't feel all wavy as I get,
You don't feel like some wave from the black hole is going through you
Really?
all the time. No, that's true.
Yeah.
Yeah,
I was just wondering because.
It's hard to get your head around that.
yeah.
What's all going on.
In part, I think so.
It's pretty exciting.
Yeah,
I think it got
I was in a
all the
couple
way.
years watching like a daily picture of someplace in the universe. It was,
Wavy.
Yeah.
Gravitational thing?
yeah, a gravitational vector, here's the base thing, image.
Well, I guess you could. Can we make the transporter be that? That's what I want to know. Where's my hover car?
The Jetsons.
Show me why there's.
So, or you can go by, I don't know how many.
So you put the wire.
We're gonna do that. How you doing?
Good.
So that's how, I just take a short end like this one, just like this before I.
I got about 10.
Oh, you got them, sorry. Oh, that. You could,
Your test out.
yeah.
So it's not like that.
And then twist the end.
So if you have any extra titanium little tip,
Twice as much.
Cool, excellent. So, if you want to start with something that is more just on the programming side rather than catching up with the LED bit immediately, I would treat it as a first step to make sure the software is installed properly and talking to the board. The file example basic link is the most basic. And that'll tell you if you're actually communicating properly.
Yeah, I'll definitely do that and then try the LED.
Some problem there. Some problem there's contact between the
Oh,
wires.
there we go. Excellent. Excellent.
They're a little too long.
That makes sense. There we go. That was much nicer. That's a lot of light.
It's a matter of like trying to get this and this and here at the same time without burning myself. Like how do you move the wire there? Oh, there.
I think you're right. These are a little too short, so I'm looking to kind of burn it, so. Okay, this one is probably not going to be there, I just see how it is. Check this out.
This one's wire is too big.
are down, right?
Yeah.
The bowls, we-
No, yeah, yeah, do the get the poll, and that'll get to the program called RGB. VN, comes from this here. Around here and. Down the street.
I'm not doing this before. I thought we were just gonna- Like the software, the hardware is something.
Thing. That's something you can do eventually outsource.
That's an idea.
Look out behind, man.
You outsource to.
I need to do my outsource.
I heard my name right.
So. It's like, you know, when you don't show up at a committee meeting, you get $10 work.
What's,
Oh, we're gonna miss.
There is.
so have you found a PWM pin?
Flight
No, I wasn't looking for faded.
Oh, okay. Pin 1 is a PWM pin, no? So you can do at least one channel fading, but,
I think it's 3 is too.
what's that?
Apparently pin 3 is.
Oh, okay.
Pin 2.
Yeah, it's too small for me to read, but yeah, I believe you.
That's what just been.
Great.
Oh, pin 0 and pin 1 as well as pin 4 support the standard analog right function.
Okay, great. Then in fact, you could do all three fade if you wanted to in the same way. Yeah. But you're going to want to be in ground 5 volts. So if you take your 9-volt battery, put it into VN and ground, then it's going to drive the Arduino, and you'll want to take the VN side to on the LED strip where it says +12.
Okay, so which the ground goes on the black?
Yeah, black is the ground, and it goes to ground, and then you'll put red into VN. Yeah, exactly. And I would actually, before you solder that on, go ahead and take another length of wire to run to the input pin on the LED.
Okay, and then attach that like right interface there.
Exactly, exactly.
Who can get the code first?
Oh, it is checked into the repository. So if you double click on your desktop, so on the desktop, if you
Yeah, they have to install it somehow. You can actually wire it, so then maybe there'll be a package.
so you don't have anything saved in the Arduino class. So full Arduino class will always pull the latest code down.
So, I mean, do a git clone, put yourself in the directory where you want this stuff to be.
You just plug that in and download it, and so you'll probably have to go back to tools and make sure that the port is
Okay, so here,
But it's also. Oh, you can't send it.
I tried to just see my
Yep.
and send me this message.
Right. So in the room, there is this and we don't get it here in the Raspberry Pi, but you're actually will. And that is the and then run the package in it that will install the driver for Yeah, it wasn't. Mark discovered this last week with the Mac actually. I've tested on Windows and the Linux system.
GitHub.com / Derek J.
Trying to figure out which port.
Arduino /
Yeah, so if you go to tools and port, it should be, oh, that's a good question. My guess is it's going to be the common 3, but if you try that and it doesn't work, then you will tell is that it will also do some flashing over there. Okay, it must have been 33 then.
Yes.
Oh, there we go.
That is quite a port. I've never seen a port number that high.
Okay.
I don't know why it's.
When you were soldering your beautiful job,
Very good.
you did a much better job.
There you go.
Perfect. So you have a connection. It's happy with your link program. So what I would do as a first step is just look through the code briefly, make sure you understand the setup, setting up pin mode for output, and the digital write to turn it on and off with the delay loop in there. And that delay loop is what we were talking about. We were talking about timer function. That we didn't want to be a blocking delay like we have it in here.
Yeah, I think I understand the concepts, although I can't remember which of the analog and which of the digital. These are digital.
Digital pins are all at that side, the analog over there. That's right. That's right.
Oh,
So
there
we
it is.
use digital rate.
Okay, so animatronics.
Good, okay, well, I'm gonna try plugging all this stuff in there.
Fantastic.
Now,
Well,
suggestions as to what you're supposed to, do you just glue this to this? or-
your call. There's a sticky back that you can peel off and stick there, and that just carries your pins up to be right next to this. I actually have been finding it as convenient to leave it off the shield and just run from the pins to the prototype board. And at some point, if I that's not very useful.
This thing, you could, I guess you could put a components in there.
You absolutely could use it as a prototype board once you're ready to do a more permanent circuit.
All right, carry on here.
Fantastic.
Oh my goodness.
Yeah,
I just really just need one marker for the.
You really do, because if you get the others mixed up, your colors will be wrong. And they will be okay. It'll just be a different,
Okay, that's cool.
They're very, very weak.
Going up.
It'll always be-
Yeah, no, that looks great. The only one, so I'm not probably doing anything about this now, but as you get more soldering, the color of that one, you can see that dull color.
Yeah.
That means that you're a little bit quick on pulling the iron off, and it wasn't quite as firm as solder trying to do my.
Oh, okay.
And again, on these ones, it's just fine, but when you're looking for a more permanent circuit, you
Right. Okay.
You can't go this far, soldering everything without.
I must have a really good. It's kind of lame.
Did everyone die with a little bit of feeling?
No.
Okay. Let's try it over, Brad.
Fine, right,
We don't live in Flint, Michigan. Oh boy, news stories on that. It looks like it's much more widespread than Flint.
So,
So with the heat shrink, you and then so there's some like heat shrinking
You can do this out.
Yep. If you right click and say Arduino IDE, then it will be free.
How do I get the like?
Yeah,
Oh,
you either connect it there.
okay, so that's. Yeah, they're suggesting that at least it's join like the orange one, the red one on the base, and then the red one for the B and.
If I have a third hand. Yeah. I have a third hand.
Okay. Yeah.
So. Do we need to do it? It just works about having the orange one when it's sticking out like
What was the why? What was the
Oh,
Just made it bigger for you.
oh, cool.
He doesn't want to install here because the system preferences are saying you can't.
Oh,
That he won't change it.
It's easier just to write before.
oh, right, okay. Yes, go. I can send you a link to the webpage of this.
super low.
There, should we program the Arduino before we do the power stuff?
It doesn't really matter what order you do it in. I would, though, for the most part, not have both power and USB connected at the same time. Just in case you short, you don't want to short into your USB port.
Right, okay.
So if I do this, shouldn't be on, because I can get it in the way.
Is it in your inbox?
Is this the 12 volt?
It is, yes. That's right. I might also suggest the same thing I just you mentioned to Rich here, that, oh, you're in trouble.
Could you put the circuit diagram?
Oh, yeah, sorry. I say that only because right before class I did that, and it scared the devil out of me. That I short-circuited onto the ground of the USB. My computer popped up saying USB grew too much power, and then it wouldn't recognize anything in the USB port. And I'm like, oh no!
That's what I
That's how to get it before standard. Yeah, it has some kind of fail-safe in the USB. Really bad. But it's not a good thing to do.
Very good street.
Loops? Yeah, there were 6.
She did a beautiful job.
Oh, yes, you really did. The thing that I'd like to point out there is that all of those are nice and shiny silver. You don't have gold ones at all. That's what I want.
Really?
Yeah.
I need bigger glasses. Mine are all twisted, so it's not.
What do you got?
Fantastic.
I would, if you go to the heat gun behind the bridge and point the heat gun at the wall. Hey, you have lights.
We do,
And they even glow in different colors.
they do. So. But I like that.
That's great.
Well, I'm gonna change my grades.
guess so.
256.
So
I remember when I read it
what is that? The transistor, what is it?
Sure. So if you look at this picture here, the main power for the LEDs is coming through that plus 12 volt. And if we were to try and through this, and it's drawing almost a whole amp of power. And if we were to try and get that exposed to the main Arduino circuit, we could bring up pins or draw them. And so the transistor has 3 pins on it. The collector and the ground pin are the high zero portion of the circuit. And then the zero pin is where you put your signal to. And you can think of it as kind of a control switch that controls the amount of current that can go through the other 2 pins. And so if you have a low current circuit that can come through Arduino, it's driving a high current portion. Kind of like the relay that we talked about in the 120 circuit, but instead of having a shut off like the relay does, this is using the semiconductor nature of the transistor to channel the electrons in the high current circuit.
And so what exactly is doing? Is that also controlled?
So this is saying V in or voltage in is the input voltage to the Arduino board. And so if this was plugged into the USB port, it would be feeding with plus 5 volts, and V in would show plus 5 volts. Because you're using a 12 volt power supply, it's 12 volts.
Because actually I had this.
Oh, yeah.
Sketch.
Yeah.
Yeah, and originally I had this over because my feet was a bit too big to shove it into there. I just.
Oh, no, it was gonna be.
All right.
And I originally had realized how fast it was giving me the same. And then.
Yeah.
So anyone you would want to use your power supply, you need a transistor and you need to connect.
Well, no, not correctly. The power supply is actually going through an onboard voltage regulator. And so, one of the chips, if I make here, this chip, I believe, is the onboard voltage regulator, and that means that any voltage that goes into this is between 5 volts and I think 18 volts is the maximum that can drive your Arduino with, is turned into 5 volts. And so the main circuitry of the Arduino is 5 volts, the same as it was run off of here. But this power connector goes directly to VN, so if you wanted to access that voltage off the power supply, that's where you use it.
Because otherwise you won't get all this power levels on.
And the only thing the transistors are doing is guarding your output pins. They're not actually involved. They're the VN power circuit.
Where's it coming from?
So you're the soldering master. I have a nice new soldering iron, I bought it in September, and I've only used it once. Yeah. It's gonna get more usage.
It's called the,
RGB. So this is something that we haven't talked too much about yet. When you came to this, I've got a GitHub repository with all the code that's in here.
It's not in the example.
It is not in the examples, so the best way to do this is possibly different than the easiest way to do this. The easiest way to do this is to just go to github.com/DerekJA and pull down the zip file of it.
coming off of the.
There and then /DerekJA. And this And go to repositories. Arduino class. And pull down a zip file of the file for the Arduino class. Just downloads, yeah. Now, the way that I encourage you to do this, and the reason that we're doing this on GitHub is, have you used GitHub before? It's a source code repository, which means that whenever you make a change in your code and you push the code back out to GitHub, it keeps a history of the changes you've made. And so from a software development perspective, it makes it really, really easy to track what you've done and to not lose code. And if your computer crashes, you don't lose anything. And so it's a really good programming formalism to use all your code safe. And so if you create your own GitHub account, it's free. Then you can fork this repository and make any changes that you want and keep them stored on GitHub as well. And as I go from class to class, I'm updating the code in this. So if you're ever on one of the Raspberry Pis with a link on the desktop that says update the latest code, you can do the same on your machine once you use a command called git and then this address. Then anytime you say git pull this code down for you. And that's a way of easily keeping your machine in sync with where changes to
All right, you'll have to tell me the second time.
Yep.
And I'll try to actually.
Yeah, that's just something to think about. So if you want to go and read some of the GitHub stuff, and then ask me when you have questions.
For sure. Okay, so I'm going to just open this file and look at it.
Yeah, that's probably quicker right now.
Yeah.
It's the RGB sketch.
Well, I'm gonna get the, so I can do a little up and down or around or swirls and I'm gonna have a little MP3 board, headers, what do they call them?
Oh, please, yeah. Oh, yeah, we can go grab one that is not all mangled.
And then I'll have a 5-button switch.
And that one's all mangled. What drug you want to make?
Thanks.
I was thinking of maybe doing a motion detector on it, just to see whether or not someone walks in the room and starts shooting shots. Let's want to do like, 3 meters or something like you want to. Otherwise you're not going to
Oh, yeah. No, I guess a little loose.
Well, I certainly have an office.
Fine was much nicer for
Garrett, I think about these things when I'm plugging in.
Sure. So, you actually want to be 3, 5, and 6. So I would move that one. And then
Any two that you press, sound okay. So you can have on another board made by instruments.
Here's the issue. These pins don't actually run out to the other side. They go right and so you'll actually have to pull these guys, move them one row further closer, and then those Hey, you have colors.
Awesome. That was super fantastic.
That's great.
Well, I'm going to be so cool if I got that question now.
Oh, nice. Where you were? Whatever you need to worry about, think about it, of course.
Because I have lights now, any, yeah, so I can, my whole battery.
No, it's a
Yes. Yes. It will be a little bit dimmer than it is now, but it will still make it.
like 80% of that's better.
Great.
I'm
I'm gonna get the cool
you're on the ball.
You open up your program and then, oh, that was written in the equivalent of the.
Apparently there were reports of bizarre lights being spotted above your house.
Oh, yeah?
And the police investigated and figured somebody had built a it sounds like an Arduino project contract.
It does indeed, yeah. That's great.
And I guess
Way back in the, probably the hard part, getting in your rate and also
So what I don't understand is, how is coming in, how does it go from this pin through these and not, how does it hold this stuff?
Right. So we've got these pins, the digital pins are basically the sensitive part of this. The Arduino board is able to carry the 12 volts. The Arduino board is able to carry 12 volts just fine and pull that off of the end pin.
Okay, so that's a special pin.
It is. That's just passing through from the power supply to so the main thing that this is the connection from the color is back down to ground. And so it's this move from the power supply is this is 12 volts through the and then the return path through these guys going to ground is controlled by transistors. Because you always need two sides to a circle. You need the positive side and the negative side. And essentially, this is the large portion of the current through the negative side to ground, controlled by your output pin. And so the output pin is not actually forming part of the circuit. It's just a control of the circuit.
I think so, yeah.
Like an explanation, but.
So by these guys, they're firing, to go back to here. So, okay, so the electricity is coming in, is it coming out of there or is it going into here to control it?
Well, so here's where there's a little bit of physics explanation involved in this. You actually have your current flowing negative and positive because you have 4 electrons going to the electron sink in the positive side. But we usually think of it just exactly the opposite. Using the power center from plus. So the question of which direction is it going is actually when we answer the correct way, they're going to be normal. But in either case, with that explanation aside, let's think of this transistor as a variable. Let's say that instead of these put someone putting it on that pin, in that little pin, there's a knob that we're twisting. If we had a resistance here of 10 kilo ohms, we talked last week about the higher the resistance, the lower the current. And we turned that resistor from 10 kilo ohms down to 300 ohms. We expect a great increase in current, and we expect these lights to get much brighter. Because this side of the circuit is letting more overall current through the entire circuit. We're doing the same thing electronically with the digital output and feeding the little size of transistor.
Okay, so we're telling them to either go stronger or less resistance, right? More resistance or less.
That's right.
And that's adjusting the color they're doing.
Exactly.
So this is cycling through each one of these and being like, okay, turn this one more red, so all these are red.
Exactly. Yeah. And so what's going on again at a physics level on this is that transistors are semiconductor components. And so you've got this material that lets some electrons through, but not all the electrons through. And by varying the voltage at the emitter, you're basically providing this amplified signal of let more electrons through or let less electrons.
Which are just going directly to ground.
Which are just going directly to ground, including the loop of this circuit going to ground.
Okay, so there's more resistance, does that mean that signal is stronger?
Because the more resistance, the more current.
Okay, so we have more current going through that resistance.
It will be brighter.
Yeah.
Hey, you got lights on.
Yeah.
That's all I did was, we don't want to wet.
I just jumped across.
Whatever the job
Cool.
is.
That's so easy.
Well done, no, we can't show them.
Well, we have another chance. Let me actually, because you're getting ready to take off the end at 8:30 again. No. I'm late. Let me interrupt everybody for a second here, because we are hitting the end of things. The Adafruit order got delayed and it's late, so let's actually just deal all of that when the parts are here and sort the money out on that at that point.
No money, no parts, no money.
The Spark Fund order. So I had suggested we do a Spark Fund order this week, closing on Sunday. They have a lot of the same things Adafruit has, but some stuff that's very different. So have a look at Spark Fund. Have a look at the website. Let's start another thread on the list and close on that on Sunday night again on that. Let's actually talk a little bit about in more detail about the shipping on that. It was $34 to ship one little $3 piece from Adafruit and $36 to ship everything that we got in the order. And so essentially what we're doing is saving on the shipping by doing it as a group order. And then we're also saving a few bucks on the import fees. So I imported as makerspace since we don't pay the taxes on it. We are still getting hugely hit. It was 67 cents on the dollar, I think, when I did the exchange rate. It was 370 turned out to 530 for a whole order for all of us together. And so yeah, to be cautious. When you put the order up for Spark Fund, make sure you're aware that it's in US dollars as well. Let's close on that on Sunday. I'll place the order on Sunday night late after everybody's put stuff up there again.
I don't know if I need anything from Spark Fund, that giant Adafruit order.
You've got all sorts of toys coming. It's true. Yeah. Yeah.
Well, I want you to get 2 of everything because I know I'm going to one of them.
So we sent you an email with our stuff. Is that okay?
Absolutely. That's right. That's right. We got it all in there.
Yeah, unfortunately, yes.
Yeah.
I have to go to
Oh, okay.
So we're gonna be
Absolutely. Sure, you bet.
And maybe kind of get a heads up on what we'll be talking about.
You bet. I've also been doing this for the couple of folks that are in Vancouver. I can send you a link, so if you're somewhere near you got a place to log on and watch, you're welcome to do that too.
Oh, yeah.
We may be on the ferry, but
Cool,
we're
yeah.
part of your sister too.
I'm also posting these recorded, so I mean, you're welcome to come back and paste through. Although this is really a poor way of having the same effect of running around and working on things. It's hard to actually go back to it.
Yeah, it just kind of showed, I know, into the schedule, so.
Yeah, so that's
The
right.
Association of Physics teachers, so.
Oh, fun.
That's
Yeah,
the other
yeah,
party,
it should be.
right?
That should be neat, yeah.
Association of Physics teachers?
Yeah, that was a party.
That's science work.
That's like.
Oh, cool.
So we get to play with whatever.
Did that already.
It's like my name on there.
What is it?
Me.
Oh.
Oh, yeah, you bet.
Awesome. Makes that work. This is
Derek, let me know, if you have a chance to try the IR detector that we got in our kit.
Yes.
See if you can get that to work, because I couldn't get mine to work, but I have another one at home, and I put that in, and it worked, the remote and everything, so I'm not sure. I just tried it, if I put the plus and minus the wrong way.
Okay. I've got some extras if it does turn out to be a hardware issue. I don't know. I honestly haven't played with them yet. I got told this week that I have 2.5 weeks to get my PhD thesis out of my committee, or else I'm not graduating this term. And so I've been kind of running just in time on class prep. Oh, keep them. Oh, this is part of your kids. Oh, yeah, cool. Yeah.
Consider my, what I just said, spend a little more priority.
No, I'll get them figured out, but it's, yes, they're, there's a little bit of stress in my world currently.
I was. I went back to the job. So yeah, I do like and get it. Every time I send my it'd be like, no, I still want you to change this.
Yeah, and the idea would be that if you play on the
Oh, geez, yeah. Well, I'm at least in the situation of, all of my committee wants me gone now. They're all on the same side, and, so, saying, look, the graduate secretary is, you don't approve these changes in the next 2.5 weeks, I'm not getting out. That means that there's actually getting more weakness than letting me get but it's not easy to do.
When I first came to
I'll put it in a box. You don't see it.
I had a very difficult PhD experience because I came in with strong industry background and I have been doing my own thing here and had a fairly synthetic supervisor. I've been kind of an arm's length PhD student in a lot of ways, which has been fun and fun. Right. I also have It's true. It's on the use of low-cost electrographic devices and diagnostic communication deficit disorder. So I've taken some gaming EEG for brainwave reading and kind of twisting them to being
Like little kids running around screaming, going, "Ah, they scream or something." Some of them are.
I think at some point here, Congress will be coming and talking about our laws, let's get our discussion going. I like the paper. Let me hide myself. Cool. Yeah. I do want to suggest that this is a very ambitious project. Is this already gone to Kelvin?
Yeah,
Yeah. Okay. Great.
I mean, I really put the amount of time into it.
Yeah. Okay. Cool. Cool.
Thank you.
Thanks a lot. Have a great day.
I'm spending a lot of time with the ads and stuff.
Yeah.
That's going to be, like, well, for me, that's going to be the first. I mean, it's just a couple of cuts.
I mean, the biggest obstacle to my eye actually is the gyroscopic control by and control systems for your.
Oh, yeah. I don't think.
Did I misread that?
Maybe I ambiguously worded. I meant to say that it'll be as I continue, that'll be one of the next.
Oh, good. I probably misread that then, because that's going to be freaking tough.
Oh yeah. That's going to be a lot of like calibrating.
Yeah. The actual timing portion, I think, is you're going to be able to carry that off pretty well.
Yeah.
And the locking mechanism to lock and hang in there, it's going to take some.
I'm just trying to figure out what kind of motor to use. I also didn't. I talked to my friend for that.
Yeah.
Good on
Same guy whose dad had the sketches soldering.
Yeah.
And I was looking for precious motors, and he said, well, you're going to want to be able to track the distance. I'm like, okay, maybe I need a stepper, but in my experience, like
Right.
Cheap steppers, we melted ones. So.
Yeah. So yeah.
Do you get my ID card or would it still be?
Oh, I'm sorry, I did not get over to get it.
No worries,
It's sitting at
I'll get it.
security still. Thanks.
Good night.
Good night. Yeah, so one thing you might think about in there is when you're in the hanging mode, you want to use no power whatsoever.
Yeah.
And so if you did something like a solenoid pushing a spring out